Okay, so now we're going to go on to the next page. And we all like to have our shortcuts, right? Makes life a lot easier. And synthetic division is the shortcut for dividing polynomials. It's a lot quicker when you get the hang of this. And so what we're going to do is the number we're dividing by, okay, is x plus 3 here. Now this only works when you're dividing by x plus or minus a number. That's what this says right here. X plus or minus some constant value. If there's a 2 or any number out in front there, that doesn't work. We can't do synthetic division. Okay? So, if you were to find this, if I said x plus 3 is a factor, and if I say, look, let's find that the 0 there, so you'd set that equal to 0, so x equals a negative 3. So what we're doing is looking at that. We're going to change that sign and write that out in front. And this looks a little bit different. So it's like that. Okay. And what we do is just write the coefficients in front of each of the terms. So our x to the 4th term, the number out in front there is just a 1. So this represents the x to the 4th, x cubed, x squared, because remember, once we start, we have to go 4, 3, 2, 1, and the no x is there. So the number in front of the x to the 4th is just 1. Number in front of x cubed, there's nothing there, so that would be the ones that we have to add in there. In front of the x squared is a negative 10. In front of the x is a negative 2, and the constant is 4. Okay? So normally you would not, once you get the hang of this, you don't need to write that in there at all. You can just leave that off there. I'll just write that in there to show you what each column represents. When you do synthetic division, first step, you just drop down that 1. Automatically every time, whatever it is, you just drop that down. Then we multiply these two numbers together. So negative 3 times 1 is a negative 3. Now we just add 0 plus negative 3, negative 3. Same thing. Multiply, add, multiply, add. So now negative 3 times a negative 3 is 9. Add them together is a negative 1. A negative 3 times a negative 1 is a positive 3. Add those together is 1. 1 times negative 3 is a negative 3. Add those together is 1. So, if I show you some examples from what we've done before, now we're going to translate this to our answer because we're not done yet. If I look at this right here, that started out as x squared and our answer started with x. That started with x cubed and our answer started with x squared. Okay, because this was divided by, that same type of thing. Our very first example we had, that started with x cubed and our answer started with x squared. So it's always one less than what we started with. So if we started with x to the 4th, then this guy would represent x cubed. So we'd have 1x cubed, and then just go down in order. Minus 3x squared. This would be the x. This would be the constant by itself. And this last guy right here is always your remainder. So that would be plus 1 over, and what do we divide it by? We divide it by x plus 3. So you can see how this would be a shortcut instead of having to do that really long division. This is just a nice little shortcut, but it only works when it's in the form of x plus or minus a number. But we know that that would be our final answer there. Okay, so now we have the remainder theorem. And what the remainder theorem is, if I was to take this number, because it says f of negative 1, that means you're going to take a negative 1 and plug it in for every x and tell me what it is. Okay? Well, the remainder is something uses synthetic division, and we'll be able to tell you that pretty easily. Okay? So let me show you how we're going to do this. Let's set it up as we would doing the synthetic division. So the 4's first, that's the cubed, squared, the x, and then the number. Now, that number just goes straight out here. What you're wanting to plug in just goes right out there. Now let's do synthetic division. So drop down the 4, multiply, add, multiply, add, multiply, and add. So since it's the remainder theorem, all we want to look at is the remainder, and that's your answer. So f at -1 is just equal to 1. So that could really save your time. Now I know you might say, well, wouldn't that be easier if you just plugged it in? Okay, but let's say that was like f of 3/4 or 136 or something like that, and it'd be these big weird numbers, and cubing it and squaring it and doing all that, and then having to do all that. You might get a lot done. Might get it done much faster if you just do synthetic division. It's always the remainder. That's your answer. There you go. And we're finally to the last page of this note. So example number 7, the factor theorem. It says factoring a polynomial using repeated division. Now if I just gave you this big, long, huge thing and I said factor it out, you guys would probably have a cow. So would I. Okay? Not fun to do. But what they have given you says show that these two guys are factors of that, and then factor out what you have left. So it kind of gives you a hint what to start with instead of having to do it all from scratch. So let's do what we're going to do is synthetic division several different times to make life easier than using the long division. So what I'm going to do right now, I'm going to use the x minus 2 factor. If I was to write out the synthetic division, that's a minus 2, so when I do it here, it's a positive 2. 4, 3, 2, 1, 0, so all the exponents powers are accounted for. So we have 2, 7, -4, -27, and a -18. Those are all the numbers out in front of each of those. Drop, multiply, add, multiply, add, multiply, add, multiply, and add. Now, our remainder there, of course, is that last number, and that's a 0. So we do know for sure that that factor right there, that this is a factor of what we started with, because since there's no remainder, it's just like 10 divided by 2 is 5 with no remainder. So we know that's a factor of 10. So x minus 2 is a factor of this long polynomial because the remainder is 0. So if I was to write out what we have so far, we'd have x minus 2 times, now remember, it started with the 4th, so we drop that down to cubed, plus 11x squared, plus 18x, plus 9. That's what we have. But the nice thing is here, if I was to say factor that out, you'd probably still have problems because then that's still a big mess to factor out right there. But we do know that x plus 3 is another factor of it. So what I'm going to do is now do the x plus 3 factor with just this piece right here, because that's what we have left over that we're trying to keep on factoring out. So synthetic division, the x plus 3 goes to minus 3 out in front. All the powers, let's check them. 3, 2, 1, nothing. So we know they're all accounted for. So we just write in the coefficients out in front and drop it, multiply, add, multiply, add, multiply, and add. And again, the remainder is 0, so when it says show that they're factors, this is showing it because the remainders are 0. So if I was to write out what we had left after dividing it yet again, we had that x minus 2 factor, and we just divided it by the x plus 3 factor. If I was looking at what we had left here, we started with cubed, so that guy is a squared, and that is 5x and 3. So now we get down to something that we can manageably factor. So I'm going to write out those first two. We know, of course, the factors of 2x squared is 2x and x. Factors of 3 would be 3 and 1. I'm going to do 3 and 1. And graph is a plus and a plus, that'll get you to the 5x, the 2 and the 3 get you to the 5x. So factoring it out, it says then write all the remaining factors of f of x. So I've taken this really long polynomial and I've factored it all the way out to this. So if you were to go backwards and you multiply all that back together, you would eventually get back to what we started with. There's no need to do that. Okay. Now let's put this together with what you've done last section also. If I were to say graph that, just as a quick review of what we've done, I know plus 2 is a 0, minus 3 would be a 0. If I did that right there, that would be a negative 3/2 is a 0. And that right there would be a negative 1 is a 0. Now again, reviewing what we did in section 2.2 with the graphing of these things, you know that it is a even power. So they're both going in the end behaviors are both going to be going the same direction, and it's a positive, so they're both going to be going up. Something like this, right? And each one of our factors does not repeat at all, so at each 0 it's going to be crossing through, not just touching it. So not graphing this to scale or anything, but the graph could look something like that. So you can see how what we did last time and what we're doing this time is all going to mush together so we can graph these wonderful long polynomials. And there you have it for section 2.3.